Unit 5, Section Circle. In this section, we will cover how to recognize the standard equation of a circle, graph the standard equation of a circle, recognize the general equation of a circle, convert from the general equation of a circle to the standard equation, find the equation of a circle given its graph or information. A circle is a set of all points in a plane that are fixed distance from a fixed point called the center in the plane. So the circle, that is the definition of the circle. There is what we know as the standard equation of a circle. The standard equation of a circle with the center at the origin. The origin is the point of intersection between the two axes x and y, which is 0 and 0. And radius r is x squared plus y squared equals r squared. That is what we call the standard equation of a circle. The standard equation of a circle with the center at h and k, so if the center is at h and k and it has a radius r, then the standard equation of that circle is x minus h all squared plus y minus k all squared equals r squared. Here is an example. Find the center and a radius of the following equation of a circle. So I have the standard equation of the circle, and it looks like it is not centered at the origin, so I will need to find the center and the radius. In order to find the center, I will take this expression and I'll make it equal to 0 and solve. So I'm going to say x plus 2 equals to 0. This will lead to x is equal to negative 2, which is basically the h value is negative 2. Similarly, I will set this value or this expression equals to 0. So I will have y minus 7 equals to 0. So we'll have y equals 7, which is the k value, by the way. So that is how you're going to find the h and k value. So the center is negative 2 and 7. Now, I have r squared here. So r squared is equal to 36. And since r is a distance, I'm going to take the square root, the positive square root only. So r is equal to 6. So the radius is equal to 6. So that is how you're going to figure out the center and the radius of the circle if you were given the standard equation of a circle. Now, if you have the standard equation of a circle and you would like to graph the standard equation of the circle, first you're going to identify the radius and the center, and then you're going to plot the center and then take a distance of the radius and create the circle. So that is how we're going to do it. So from the first equation here, I can immediately tell that the center is negative 4 and 3, and the radius is 3. So I will plot the point negative 4 and 3. Negative 4 and 3 is approximately here. That is the center. Now I'm going to take 3 units on each side. So I'm going to say 1, 2, 3 on the right, 1, 2, 3 up, 1, 2, 3 down, and 1, 2, 3 to the side. And then I'm going to try to connect all of these points together. Do your best to connect them. You don't have to be perfect. The point is to have the radius r is equal to 3 units in this case. That's all we need with the correct center. Okay, so that is how you're going to graph the first one. The second equation here, you notice that the center is 2 and negative 3. The radius is 5. So 2 and negative 3 is approximately here. And then the center or the radius is 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I'm going to try to fit the circle curve around that. Let me try one more time. And that is the graph of that circle. How about if we were given the graph of the circle and we would like to find the equation of the circle, or you were given the information about the circle and you would like to find the standard equation of the circle? So here is an example. Find the equation of the circle with the given information or graph. So for the first one, we were given information, the center and the radius. We know that the standard form of a circle centered at h and k is x minus h all squared plus y minus k all squared equals r squared. I have h and k, so all I need to do is to substitute them in the equation. So x minus negative 3 all squared plus y minus 2 all squared equals 4 squared, which turns to be x plus 3 all squared plus y minus 2 all squared equals 16, and that is the equation of the circle in the standard form. If the information was not given and instead we were given the graph of the circle, like example number 2, we will need to figure out what the center is and what the radius length is. So in this case, the center is this point, which is the point 3 and negative 5. The radius is 1, 2, 3, 4 units, so r is equal to 4. So h and k are given from the graph, and I found r. All I need to do is to substitute in the standard form or the standard equation of the circle. So that will be x minus 3 all squared plus y minus negative 5 all squared equals 4 squared. That is x minus 3 all squared plus y plus 5 all squared equals 16. That is basically the equation of the circle or the standard form of the equation of the circle. Last but not least, equation number 3 or question number 3, I have the center at 0 and 1 and the radius is 7. Again, I'm going to use the standard equation of a circle. X minus h all squared plus y minus k all squared equals r squared. I will substitute x minus 0 all squared plus y minus 1 all squared equals 7 squared. This is h and this is k. Now I have x squared plus y minus 1 all squared equals 49. And that is the standard equation of the circle given the information in question number 3. This is basically how you're going to graph the equation or find the equation based on information. Next, we're going to discuss the general equation of a circle. So the general equation of a circle is given by ax squared plus by squared plus cx plus dy plus f equals 0, such that a is always going to be equal to b. So these two coefficients should be the same. Otherwise, it's not going to be a circle. It's going to be a different shape. So how do we convert from the general equation of a circle to the standard equation? To rewrite the equation of a circle from a general form into a standard form, we simply complete the square twice, and we discussed completing the square in previous sections at the beginning of the semester. Once we're going to complete the square for x variable and once for the variable y, and then we're going to come up with the standard form. The standard form is a better form to identify the center and the radius, so it is a better form for graphing. Here is an example, and we're going to follow these steps. So convert from general form to standard form for the following equation of a circle. X squared plus y squared minus 2x plus 6y plus 6 equals to 0. I can identify this is actually a circle because the coefficient of x squared is the same as the coefficient of y squared, which is 1. The first step here is to group the x's together and the y's together, and then consider only the x square and the x terms, and then complete the square for those terms. Consider the y square and y terms and complete the square for these terms, and then we're going to simplify and add the numbers outside of the brackets together. So here is how we're going to do it. First step is to gather the x's together and the y's together. So I'm going to say x squared minus 2x plus some number, and then I will gather the y's together, plus y squared plus 6y plus a certain number, and then I have to take the constant to the other side. So this is equal to negative 6. Okay, similar to what we did before. Now we're going to figure out what number we should add here. So I will take the coefficient of x and divide it by 2 and square it. So negative 2 divided by 2 and then square it. And that will give me negative 1 squared, which is equal to 1. So I'm going to add 1 here, and I have to add it to the right-hand side of the equation as well. In a similar manner, I will need to figure out what to add to the y variables. So I'm going to take 6 divided by 2 and square it. That is 3 squared, which is equal to 9. So I'm going to add 9 here, and I'm going to add 9 to the other side of the equation as well. Now, if you consider the x terms only, I can rewrite these as x minus 1 all squared. That is the first term, the square root of the first term, the sine of the middle term, and then the square root of that number. Or it's basically this value right here. Same with the y variable, so I will be able to rewrite this expression as y plus 3 all squared. That is the square root of the first term, the sine of the middle term, square root of the third term, all squared. And then equals, and then I will add all of these together. Negative 6 plus 1 is negative 5, plus 9 is positive 4. Now you can see how easy it is to tell what the center is and what the radius is for this equation by converting it from a general equation of the circle to the standard form of the equation of the circle. Let's do another example. Find the center and radius for the following equations of a circle. So in order to do that, we will need to convert from general form to a standard form. I'm going to name this number 1. I'm going to name this number 2. So for number 1, I will convert it here. So I'm going to gather the x terms together and plus some number. And I gather the y terms together plus some number. And I will take this to the other side. So I'm going to subtract 13 from both sides, minus 13. Now, I will focus on the x terms first, and I will find the number that I will add here. So I will take the coefficient of the linear term, divided by 2 and square it. That is 4 squared, which is 16. So I'm going to add 16 to both sides of the equation. In a similar manner, I will take the coefficient of the y terms, the linear term, and I'm going to divide it by 2 and square it. And that will give me negative 1 squared, which is equal to 1. So I'm going to add 1 here, and I'm going to add 1 to the other side of the equation. The x terms, I can rewrite this expression as x plus 4 all squared. Plus, I can write the y terms as y minus 1 all squared equals, and then I will find the answer here. Negative 13 plus 16 is positive 3. Positive 3 plus 1 is 4. So the center is negative 4 and 1, and the radius is equal to 2, which is square root of 4. So that is how you can figure out the center and the radius from the general form. You need to first convert it into the standard form, which, as you can see, it needs a lot of practice. So we'll do it again. I will gather the x terms together, plus some number, and then the y terms together, plus some number, and then I will take the 4 to the other side. It goes with a positive sign because it's negative. So plus 4. Now, I will take the middle term from the x terms. I will take the linear term, linear coefficient, divided by 2 and square it. That is negative 2 squared, which is equal to 4. That means I'm going to add 4 here, and I will add it to the other side as well. Adding to both sides is essential. If you forget to add, you will get the wrong answer. So make sure that you focus when you are solving these equations and add to both sides. Again, I will focus on the y terms now, and I will take the linear coefficient of the y terms, which is 2, divided by 2 and square it. That is 1 squared, which is equal to 1. So I'm going to add 1 here, and I'm going to add 1 to the other side. Notice how this number that you add is never going to be negative. So if you ended up with negative 2 and then you said, well, the answer is negative 4, then you're mistaken, because that number cannot be negative. It cannot be negative. Now, I can rewrite the x terms or the x expression as x minus 2 all squared plus, and then the y terms, I can rewrite them as y plus 1 all squared equals 4 plus 4 plus 1 is 5. So the center in this case is positive 2 and negative 1. And the radius is the square root of 5, the positive square root of 5, because r is a distance, it cannot take negative numbers. That is the end of the circle section. Next, we're going to look at conic sections. A conic section is formed when a right circular cone with two parts is intersected by a plane. One of the four types of curves can be formed: a parabola, a circle, an ellipse, or a hyperbola. The circle, we studied the circle, and we know that the circle is the set of all points in a plane that are all a fixed distance from a fixed point called the center in the plane, with the center h and k and a radius r. The standard form is x minus h all squared plus y minus k all squared equals r squared, or we can divide everything by r squared, and we can rewrite it as x minus h all squared divided by r squared plus y minus k all squared divided by r squared equals 1. And that is how we usually write the conic sections, is this number right here should be equal to 1. The general form of the circle is ax squared plus by squared plus cx plus dy plus f equals 0, where a and b are equal. So for the circle, that is what distinguishes the circle, is the a and b are equal numbers. If they're not equal, we will see a different type of shape, which is what we call the ellipse. An ellipse is a set of all points x and y in a plane such that the sum of their distance from two fixed points is a constant. Each fixed point is called the focus. So here is the focus that we're talking about. The plural for that is foci. And this is one example of an ellipse with the major axis is on the x-axis. So how do we know the equation of an ellipse? It is similar to an equation of a circle, except for, in this case, the equation of an ellipse with the major axis horizontal, which is the x-axis, it is x minus h all squared over a squared plus y minus k all squared over b squared. And a in this case is always bigger than b. Okay, so notice that a is always bigger than b in the case of an ellipse. If the major axis is vertical, then all we need to do is to put the big number under the vertical axis, which is the y in this case. So the equation is going to be x minus h all squared divided by b squared, the small number, plus y minus k all squared divided by a squared, which is the bigger number, equals to 1. And notice here that we have this is the major axis in our case, which is the horizontal axis. And here is the minor axis in that special case. The minor axis is horizontal in the second case, and the major axis is vertical in that case. So if the major axis is horizontal, we put the bigger number under the x variable. If the major axis is vertical, we put the bigger number, which is the a, under the y variable in the equation. The general form of an ellipse is ax squared plus by squared plus cx plus dy plus f equals to 0. Notice how similar this is to the circle, except for the fact that a shouldn't be equal to b. So the circle, you can say, is a special case of an ellipse. The third conic section that you can see is what we call a parabola. And we saw parabola before. A parabola is a set of all points in a plane equidistant from a fixed line, the directrix, and a fixed point not on the line, the focus. Remember that we covered parabolas in section 5.1, graphing quadratic functions, for example, y equals x squared. But also in this section, we're going to discuss x is equal to y squared, which is not a function. All of the conic sections are not functions, by the way. The standard form axis of symmetry is y equals to a times x minus h all squared plus k, where if a is positive, it opens up, and if a is negative, it's gonna open downwards. Another standard form, in this case, the horizontal axis of symmetry, which is the one that is not a function, we have x equals to a times y minus k all squared plus h, where if a is positive, the parabola is going to open to the right, and if a is negative, the parabola is going to open to the left. So for the first one, the vertical axis of symmetry, it has a vertical axis of symmetry. So the parabola is going to open upwards if a is positive and downwards if a is negative. We discussed that in section 5.1. The horizontal axis of symmetry, if it has a horizontal axis of symmetry, which means the parabola was going to open to the right if a is positive, and it's going to open to the left if a is negative. And in this case, the parabola is not a function. The last shape of conics is the hyperbola. A hyperbola is a set of all points x and y in a plane such that the difference of the distance between x and y and the foci is a positive constant. You notice the equation is very similar to ellipse, except for the sign here is negative instead of positive. And similar to the ellipse, if the equation opens left and right, you will see that that A is going to be under the horizontal axis, which is the bigger number. A is bigger than B. And if the hyperbola or the equation opens up and down, so for the first one, here is the graph. And here are the foci. The center, in this case, the center is at 0 and 0. It is usually at h and k, but this one is special and it's centered at 0 and 0. We have also the asymptotes. These are the asymptotes. The parabola is going to approach but will never touch. And then we have the vertices, which are the points on the hyperbola that are closest to each other along the axis of symmetry. So these are the vertices of the hyperbola. We also have the axes, which are the transverse axis. This is the transverse axis, and this is the conjugate axis for that hyperbola. So these are the information about the hyperbola. You do not need to know any of that. You just need to identify the shape based on the equation provided. So if you can distinguish between the three, distinguish between hyperbolas and ellipses, then you will be able to identify each one of them. Also, the circle can be written in this form as well, which will be, in that case, a squared will be equal to b squared, which is basically r squared. If the equations opens up and down, so the equations open like that, then the transverse axis is going to be vertical, and the conjugate axis is going to be the horizontal one. And we have the foci on the vertical axis. Equation is going to be written different. So the bigger value, which is the a, is going to be written under the y-axis or under the y variable, as you can see here. So instead of switching a and b, they switched the y and x. So you can see here that a was switched with b. Instead of switching a and b, they switched the y and x. So these expressions were switched. And notice how the negative goes always with the smaller denominator. So the negative goes with the smaller denominator, and that is another way to distinguish the shape of a hyperbola. Again, what we discussed so far. So the general form of a hyperbola is ax squared minus by squared plus cx plus dy equals f plus f equals to 0. Note the minus sign between the squared terms. So that is how you distinguish an ellipse from, this is how you're going to distinguish between the hyperbola and the ellipse. The ellipse is going to be positive in between the squared terms. The hyperbola is going to be negative in between the two terms. What you need to know in this section is how to identify a conic sections based on a given equation. So if you were given x squared equals to 6y, notice how only the x is squared. So this is not going to be a circle. It is not going to be an ellipse. It's not going to be a hyperbola. It is a parabola. So that is the choice. That is the correct choice right here. Parabola is the correct answer. The second equation, x plus 2 all squared divided by 49 minus y minus 3 all squared divided by 9 equals 1. Notice how this is a minus in between the squared terms and the denominators are not equal to one another. So it is not a parabola, it is not a circle, it is not an ellipse, so it is a hyperbola. An ellipse, the sign is going to be positive in between the squared terms. Number 3, x plus 2 all squared divided by 49 plus y minus 3 all squared divided by 9 equals 1. This could be a circle, however, I know it's not a circle because the denominators are not equal, so this choice is going to be an ellipse. It is not a parabola, it's not a hyperbola, it's not a circle. It's not a circle because the denominators are not the same. It's not a parabola because both the variables x and y are squared. It is not a hyperbola because the sign is not negative. Next, I will have x plus 2 all squared equals 4 times y minus 3. So I see here that the x is squared, but the y is linear or not squared. So this is not an ellipse, it's not a hyperbola, it is not a circle, it is a parabola in that case. Next, x squared plus 6y plus y squared minus 2x equals to 4. Notice how x squared and y squared have the same coefficient. So I'm going to say this shape is going to be a circle, and the sign, if I rearrange the terms, it's going to be x squared plus y squared plus, minus 2x plus 6y minus 4 equals to 0. So what I care about is the sign and the coefficients of x squared and y squared. The sign in between them is positive, and their coefficients are the same, so that is basically a circle. The next equation, x squared plus 6x plus 4y squared minus 2x equals 4. So notice how if I rearrange the terms, this is going to be x squared plus 4y squared minus 2x plus 6y minus 4 equals to 0. First of all, the sign in between x squared, y squared is positive. However, the coefficients are not equal, which makes it an ellipse. So the choice is C, and the answer is an ellipse in this case. It is not a circle because the coefficients are not equal. It is not a hyperbola because the sign is positive in between the x terms and the y term. It is not a parabola because both x and y are squared. It is not a circle. Last but not least, number 7, x squared plus 6y minus 6y squared minus 2x equals 4. If you rearrange the terms, you will get x squared minus 6y squared minus 2x plus 6y minus 4 equals to 0. Again, what I care about is those two terms. The coefficients are not the same, and the sign is negative, which means it is not an ellipse, it is a hyperbola. It's not a parabola because both x and y are squared. It is not an ellipse because the sign in between them is not positive. It is not a circle because the coefficients of x squared and y squared are not the same. Now, this is going to be for you to catch some notes and find the difference and similarities between the circle and ellipse and parabola and hyperbola. And you can write it in your own words. Find what distinguishes the circle from the ellipse, from the parabola, from the hyperbola. Write down your notes. You don't have to stick to what I am going to write down. For the circles, you notice that the both x squared and y squared have the same coefficient, and the x squared and y squared are both positive. So it's going to be written like that. So x squared and y squared are going to be positive. And this is how you're going to identify it quickly. If you identify those two traits, then you will have a circle. The ellipse, again, both x squared and y squared going to be present, so you'll see them. Same here, so x squared and y squared are present, meaning you can see both of them. None of them is missing. And then the coefficients of x squared and y squared are different but positive. So x squared and y squared have different coefficient, but both are positive. So both are positive. So that is how you're going to identify an ellipse. A parabola, only one will appear. That means either you're going to see x squared or y squared, not both of them together. So either you're going to see x squared or y squared. And that is probably the main difference between the parabola and the rest of the conic shapes, because the hyperbola will have both x squared and y squared are present. So if you see, let's say, x squared and then you have a y with that, that is a parabola. If you see y squared and an x with that, then that is a parabola as well. The last shape is the hyperbola. Again, both x squared and y squared are present. Okay, both of them are present. The coefficients of x squared and y squared are different with opposite signs or the same with opposite signs. So coefficients of x squared and y squared are opposite signs. They can be the same, but they have opposite signs. One is going to be positive and the other one is going to be negative. They're not going to be the same sign. They can be the same though. They can be similar to one another. So that is the most important characteristics to identify each of these shapes. Now you can use your own words to express that better. I gave you pointers here and you can fill in this sheet of information and understand it. So I hope that was helpful. That is the end of the circles and the conic sections. And this is the end of course material for the semester. If you have any questions from these sections, please let me know. Good luck with your finals. Again, if you have any questions, reach out to me.